Good morning, everyone. Myself Suresh, lecturer in mechanical engineering, Government Polytechnic, Gomara. So today we are going to deal with the subject called Basic Workshop Technology. Okay. So in this subject, today we are going to discuss about from the chapter called Carpentry. So on completion of this period, so you will be able to know about the what is carpentry and identify various carpentry tools and also marking and measuring tools used in carpentry, and also they explain the construction of carpentry tools. Okay, next state the specifications of these carpentry tools and also use of those carpentry tools. So first we'll learn about actually what is a carpentry. So have you ever seen a manufacturing of doors, windows, wooden furnitures, etc.? So can you name the name of the manufacturing process used? So the manufacturing process is called a carpentry. So in this lesson we learn some basic concepts of carpentry. Okay. So here we can see the picture of some of the carpenter tools using. Okay, so by using those tools, so here we can produce a required component. So actually what is a carpentry? So it is a process of wood to obtain a desired shape and size of goods and components like doors, windows, roofs, partitions, etc. Okay, so the tools used in workshop, that is in carpentry, are known as carpentry tools. So now we can see the some of the carpentry tools. Okay, so they are marking tools and measuring tools and also cutting tools, boring tools, striking tools, holding devices, and also miscellaneous tools. So first of all we will learn about marking and measuring tools that we can see here. So these tools are used for marking, measuring, and checking the work at various stages. So we can see here. So first tool is a pencils and pencil compass. You can see here. So here we can see the different types of pencils. So okay, so we can see various types of pencils here, that is H, 2H, HB, etc. are used for making dimensions and contours on work, okay, of a wood. So a special bigger size compass is used for drawing circles of 25 mm to 500 mm. Okay, so there is a special sized compass, so which is used to draw a circles of 25 mm to 500 mm. Okay, next we can see here carpenter's folding rule. Okay, so it is a foldable wooden scale used for measuring and setting out dimensions up to 600 mm. Okay, so it consists of four pieces, each is 6 inch or 150 mm, joined together by means of long pins and hinges. Okay, so these folding rules can be folded in a single piece length. Okay, next we can see the figure here. So this is the actual for folding rule figure. Okay, so this is generally used in our carpentry shops. Next we can see the steel tape. So we can see here. So these are the pictures of steel tape. So this steel tape is used for measuring longer dimensions. Okay. So this steel tape is a flexible one. We can use it here, and this can be coiled. Okay, and rolled in a case. So within the case, so the steel tape can be folded or coiled. Okay, and the range of this steel tape is of about 0.6 meters to 2.5 meters. Next one is steel rule. You can see the diagram here. Okay, so this will be a steel rule. So this steel rule is used for measuring and setting out linear dimensions with an accuracy of 0.5 mm. Okay, so what will be the accuracy of this steel rule? So that is 0.5 mm. So by using this steel rule, you can draw a linear dimensions. Okay. Next, so this can be made of stainless steel and graduated in inches and centimeters. So this steel is made of stainless steel, and the lines which are there on the scale, that is those are called graduations. So those are in inches and centimeters. Next, so this steel rule is available in different lengths. So ranges from 150 mm to 600 mm. Okay, so next one is a straight edge. Okay, next we can see the separate tool, that is called a straight edge. This is a special tool. We can see here, see the diagram here. So how we are using the straight edge? So by using a scriber. Okay, so the straight edge is used for testing trueness of surface and edges. Okay, so where we are using, so this is used for testing the trueness of surfaces of the workpiece. Okay, and also the edges. So it is used, so it is a flat piece of wood or a metal. So this steel edge is either wood or a metal, and has truly straight and parallel edges. So what is it is having? So it has truly straight and parallel edges, as the figure it shows. You can see here. Okay, so on the workpiece, wooden workpiece or metal workpiece, so if you want to draw the straight lines, okay, or parallel lines, so we can use the straight edge. So by using the scriber, we can able to draw the parallel lines or straight lines, and also so we can find out the trueness of the surface of the wooden workpiece or metal workpieces. Next we can see the another tool, that is called a tri-square. Let we can see the diagram here. Okay, so left figure is a tri-square, and the right figure is the usage of a tri-square. So you can see the figure here. Okay, so it has different parts. So they are stock and blade. So blade is attached perpendicular to the stock at the left end. Okay, we can see the left figure, first figure, that is first figure. Okay, next, this is used for testing flatness of surface. Okay, this tri-square is used to testing the flatness of surface, and also for marking parallel lines. So by using this tri-square, so we can also mark parallel lines. Okay, next, marking and testing of right angles. Okay, we can also check the wooden workpieces or metal workpieces, it will be at right angles or not. We can check by using this tri-square. Next, So these tri squares are available. Okay, the size of blades ranges from 100 mm to 300 mm. So this will be the blade ranges. That is the size of the blades which ranges from 100 mm to 300 mm. Okay, as we can see the figure here, second figure. Okay, so here it shows the usage of a tri square. Okay, next we can see another figure of a tri square. Okay, you can see here movement of the scriber, engineered scriber, how we are drawing the lines, parallel lines. Okay, by using a engineer's tri square. Okay, next tool is, that is a bevel square. Next tool is nothing but a bevel square. We can see the figures here. Okay, so right side we can choose, you can see the figures of a bevel square. So this bevel square is also called sliding level. Okay, so this is also called as sliding level. Next, this bevel square is used for marking and testing of any angle. Okay, so which is between 0 to 180 degrees. If the workpiece consists of some angle that is within the 0 to 180 degrees, so by using this bevel square, so we can test the angle, or we can find out the angle between 0 to 0 degrees to 180 degrees. Okay, we can use this one. Okay, that is a bevel square, and also is also used for marking and testing. Okay, next, so it has a slotted blade. We can see here in the bottom figure, we can see clearly, it clearly shows that there will be a blade. Okay, so it consists of a slot. The blade consists of a slot. Okay, and there will be a stock. Okay, so it is made with a wood. You can see the figure, bottom figure. Okay, so it has a slotted blade and stock, and can be set any position with a screw. So by using a screw, so we can adjust the, that is blade. Okay, at any angle, that is from 0 to 180 degrees. Okay, so by using a screw. Next we can see here. Okay, this is the another diagram. Okay, of a bevel square. Next we can see the usage of bevel square, how we are using the bevel square. We can see here, observe the figure here. So loosening blade and adjusting the blade to draw the lines. So loosening blade, first one. Next, after that, tightening the blade by using a screw lock. Okay, we can observe keen here. Okay, right. Next one is a meter square. Next tool, next tool is a meter square. We can see the figures here. Okay, so these are called a meter square. So this meter square is used for marking and testing 45 degrees. Okay, so if the workpiece, it should be there should be 45 degrees or more. If the workpiece is having at an angle of 45 degrees, so by using this meter square, so we can mark and test the up to 45 degrees angle. Okay, so the blade is fitted to stock at an angle of 45 degrees only. Okay, next, so this meter square is available in the range of 150 mm to 300 mm. Okay, so this will be the range. Okay, that is size of the meter square, that is 150 mm to 300 mm. Next we can see the a combination square. This is very important. Okay, so this will be a, that is nothing but combination square. We can see the combination square here diagram. So observe the parts of this combination square. Okay, here we have different parts. We can see a graduate rule, locking screw, spirit level, square head, bevel protractor head, vernier scale, and also there is a center head. Okay, so these are the various parts of a combination square. So now we can see the brief discussion of a combination square. So it is useful tool and consists of a square, bevel square, that is nothing but protractor head, center head, and a rule. Okay, so this combination square is used for checking angles. Okay, so this is used for checking angles, trueness of the workpiece, that is workpiece surface. Okay, and also for marking centers on end of round of jobs. Okay, so this is used for checking angles, trueness of surface of the workpiece, and also for marking centers on end of round jobs. Okay, next we can see the diagram, combination square diagram, actual diagram. Okay, so here we can see the different parts, that is nothing but a protractor. Okay, we can see the round protractor here. Okay, so that is, it consists of a some degrees. Okay, next topic is nothing but marking tools. Okay, next we can see the marking gauge here. Okay, so we can see here, so how we are using the marking gauge. So we can observe the parts here for the marking gauge. So in first figure we can see the different parts of a marking gauge, that is stock, stem, thumb screw, and marking pin. Okay, in right figure, so we can see the usage of the marking gauge. Okay, you can observe the figure here. Okay, next, so where we are using this marking gauge, so it is used for cutting parallel lines, okay, along the grains at a given distance from an edge. Okay, suppose if you have a wooden workpiece, if you want to draw the parallel lines on the wooden workpieces, okay, so first you have to select the marking gauge. Okay, select a suitable marking gauge and take the suitable workpiece and draw a parallel line along the grains of the workpiece. Okay, so that we can draw a parallel lines on the wooden workpiece. Next, so it has a stem, okay, with a sharp pins at one end. So for this marking gauge, so there is a part called stem. So at the stem, so there is a sharp pin at one end. If you observe the figure, first figure, for the right side, of the stem, so there will be a marking pin. Okay, that is a sharp marking pin. Okay, next, the distance can be adjusted by sliding the stock, that is nothing but head on the stem. So on the stem, so we can adjust the stock, okay, based on the requirement of the distance, so that we can slide the stock on the stem. Okay, next, Next we can see the diagram, actual diagram of a marking gauge. Okay, so by using a thumb screw, so we can adjust the stock on the stem. Okay, so this marking pin is also called as screw pin. Okay, next we can see the diagram here, usage of the marking gauge. Okay, clear. Next we can see here another figure, usage of marking gauge. How we are you drawing the parallel lines on the wooden workpiece. We can see that is a finished one, starting point and middle and finished. That is the usage of a marking gauge to draw the parallel lines on the wooden workpiece. Next we can see the marking tools. That is nothing but first one is mortise gauge. Okay, so it is somewhat looking like a marking gauge. Okay, so what's the difference? So it has two pins at the one end of other end of the stem. So there is a stem here also. For this stem, the other end is having two pins here. Okay, first one is a fixed pin, the other one is a movable or adjustable pin. Okay, so there is a head here, head or stock. So we can adjust the stock or head on the stem, so by rotating the locking screw, so that we can adjust the head or stock on the stem as per the our requirement. That is nothing but distance required to draw the parallel lines on the wooden workpiece. Next we can see the here. So mortise gauge is used for cutting two parallel lines in a single stroke. In a single stroke, so we can draw the two parallel lines here. Okay, so in the previously we have seen that there is only a single line we are drawing on the wooden workpiece, but here by using this mortise gauge, so here we are using two parallel lines in a single stroke. Okay, so by using a moving pin and also a fixed pin, we can draw a two parallel lines in a single stroke. Okay, next, so it has two sharp pins. Okay, it is also similar to the previous one, that is nothing but marking gauge. It looks like a marking gauge, but it has two pins. Okay, so it has two sharp pins, so one is fixed to the stem and the other is a brass. Okay, that is nothing but a movable pin. Okay, which is also fixed on the stem, so that okay. Next we can see a mortise gauge figure. Okay, here we can see, so there are two pins here, there is a slot. Okay, there is a slot to slide the movable pin on the stem. Okay, so by using a locking screw, so we can adjust the stock or head on the stem. Okay, along with a movable pin. Next we can see here. Okay, so there is a screw locking screw. Okay, fence locking screw, fixed screw, and also a movable screw or pin, a fixed screw or pin. Okay, next another figure we can see here, T519 mortise gauge. Okay, here we can see the usage of a mortise gauge. Okay, you can see here the movement of the thumb screw or brass screw, so that we can adjust the movable pin in the stem. So yellowish color is nothing but the thumb screw or brass screw. So the end of this thumb screw, so there is a movable pin. Okay, to adjust the distance or to draw the required distance of the parallel lines, so we can adjust the thumb screw, so that we can draw the required distance of two parallel lines at a single stroke. Next we can see another figure here, usage of mortise gauge. Isn't it? It's clear. Yeah, that is a usage of the mortise gauge, that is to draw the two parallel lines in a single stroke. Okay, on the wooden workpiece. Right. Next we can see here another type of marking tools, that is panel gauge. Okay, that is nothing but panel gauge. These are the panel gauge marking tools. Okay, so it is also similar to a marking gauge. Okay, it almost similar to marking gauge. So it has a long stem. So for the previous two tools, that is mortise gauge and marking gauge, there will be a small stem, but here there is a long stem. Okay, that is for panel gauge. So it almost similar to marking gauge, so but it has a long stem, so which enables to mark wide boards. Okay, so for white boards, okay, like door panels. Okay, so this panel gauge is used. Next marking tool is, that is marking knife. So here we can see the left side, we can see the diagram of a marking knife. Okay, and the second figure, that is for the right side, usage of a marking knife. So how we are using the marking knife, in the second figure it shows. So by using a tri-square, so we can draw the lines, or we can draw the marks on the wooden workpiece or wooden surface, so by using a marking knife. Okay, next, so this marking knife is used for converting pencil lines into cut lines. So previously on the wooden surface, so we are drawn markings by using some pencil lines. Okay, so after that, so by using this marking knife, so we can convert that pencil lines into a cut lines. Okay, isn't it? It's clear. So by using this marking knife, we are converting the pencil lines into a cut lines. Okay, I think you are clear. Okay, next, so what is the use of this one, we can see here. So it has a chisel edge at one end and a sharp point at other end. So for the marking knife, we can see two ends here. So one, that is for the left, that is first figure, we can see, observe the two different shapes. Okay, so in the first figure, for the left side, so there will be a, looks like a chisel edge. Okay, so and other side, so there is a sharp point. Okay, so for the by using the sharp point, so we can draw the, or we can cut the metal piece, that is in the pencil lines is converted into a cut lines. Okay, and this is also known as a scriber. Okay, next tool is we can see here. So this is these are the different types, different marking knives we can see. Okay, next we can see the usage of the marking knife, how we are using the marking knife on the wooden workpiece or wooden surface. Okay, if you want to cut the pencil lines into your cut lines, so we can use this marking knife. Okay, by taking the support from the tri-square, so we can draw the, or we can cut the pencil lines, or we can convert the pencil lines into a cut lines. Okay, it's clearly showing that how we can use the marking knife to draw the cut lines on the flat wooden workpiece. Next tool is next are measuring tools. Okay, next we can see the some measuring tools here. Okay, that is first one is caliper. Okay, already we know about the caliper, what's the use of caliper. Okay, so in previous classes or in previous in previous classes we discussed about some of the measuring tools. Okay, if you are remember or not, I don't know exactly, but already we have discussed some of the measuring tools in previous classes. Okay, so now we can see here. So the first one is a caliper. So what is the necessity or what is the use of this caliper? So this caliper is used for measuring the size of the workpieces. Okay, so in carpentry, if you want the, if you want to measure the size of the workpiece, so we can measure by using a calipers. Okay, and also to transfer the same, okay, same measurement to the steel rule to read the dimensions, so what exact dimensions. Okay, next, so it has two legs. Okay, so for the calipers, so it has two legs. Okay, first those are hinged together at one end, so it looks like this. Okay, so here these two are the two legs which is hinged to the a fixed point here, that is one end. Okay, so this is a fixed, that is pivot point. For this pivot point, so we are fixing the two hinged legs. Okay, next next is the size of the caliper. So, okay, size of the caliper is the maximum distance that can be opened. Okay, there's nothing but, so how much distance we can open these two legs, so that will be the size of the caliper. Okay, size of the caliper is the maximum distance that can be opened between the two legs. Okay, that will be the size of the caliper. So based on the type of joint, based on the type of joint of these two legs. Okay, so we have two calipers. Okay, so they are firm joint caliper and spring joint caliper. Okay, so based on the type of joint, there are two calipers. So first one is firmed joint caliper, second spring joint caliper. Okay, now we can see the diagram of the outside calipers. Here we can see the foam joint caliper and also the spring type. In first one we can see in figure 16. So first figure is a firm joint caliper, and second one is spring joint caliper. Okay, and also the usage of the caliper, how we are measuring the diameters or size of the workpieces in carpentry, we can see here. So first one is nothing but outside calipers. Okay, so outside calipers. So for the outside calipers, the legs bend inward. Okay, so like this. So it opens inward. Okay, so it is used for measuring outside dimensions of the cylinders. Suppose if you want to find out the outside diameter of a chalk piece, so we can use this outside caliper. The legs are bent inwards, and we can find out the outer side dimensions of the cylinders. Okay, and also the thickness of the plates. Okay, the legs are bent inwards. Okay, so that we can find out the diameters or thickness of the plates. Okay, so by using outside calipers. Next we can see here the figures of the outside calipers of a foam joint and also a spring joint. We can see here. Okay, right. Next we can see here outside calipers measurement. How we are using the measurement? How we are finding the measurements? Okay, we can see here. Observe the figure so that we can get the how we are using the outside calipers measurement. So next is inside caliper. Okay, so this figure is not showing clearly. Okay, so it is in blackish color, so it is not visible directly. Okay, right. So what is the inside calipers? It is also all the purpose is same, but here the legs are bent outward. Okay, not like inward. Okay, so in previous one is the legs are bent inward, so to find out the diameters or thickness of the plates. Okay, but here if we want to find out the inner dias of the hole or a pipe. Okay, so if you want to find out the diameter of holes or pipe diameter, so by using this inside calipers, so we can able to find out or measure the inside diameters of the holes or pipe diameter. Okay, and also the width of keyways or recess. Okay, so we can see here either it will be a foam joint caliper or a spring joint caliper, whatever it may be. Okay, next we can see here, this is the diagrams of inside a caliper. We can see the legs where it is bent either inward or outward. We can see here. So in here we can see the legs are bent outward, not inward. For outside caliper, the legs are bent inward. For the inside caliper, the legs are bent outward. Okay, so that we can find out the diameter diameter of the hole or some cylindrical holes, or we can easily we can find out the inside diameter of the pipes or holes. Okay, next we can see the diagram of the usage of the inside calipers. How we are measuring the inside calipers, we can see here. Observe the figure carefully so that we know the how we are using the inside calipers. Okay, next next measuring tool is a divider. Already we know about divider, so you can see here. So this divider is used for transferring the measurements from rule to wooden surface. Okay, so whatever the measurement we are taken from the steel rule, so that measurement is transferring to the wooden surface. Okay, so that we can draw the circles, or we can transfer the that rule measurement into a onto the wooden surface, so that we can draw the scribbling circles and arcs. If you want to draw an arcs or circles, so those measurement transfers is transferring to wooden surface. Okay, so that we can draw the circles or semicircles or arcs. Okay, is it clear? So right, we can see here. So it has two legs and can be set by a screw and nut. Okay, against the a circular spring. So there is a, in the top we can see here, there is a circular spring. Okay, and for that circular spring, so we are having two legs are connected. Okay, by having a set of screw. Okay, by rotating the set of screw, so we can adjust the legs of the divider. Okay, isn't it clearly? Okay, we can see here different dividers. Okay, so I conclude now. Okay, fine. So today already we discussed these topics, so I will stop here, and the next class I will continue the same topics. Okay, thank you.